Hey everybody, in this video, this is going to be covering the first study guide for Unit 1. The video won't go through all parts of the study guide because some of it is just writing down and basic things that I wanted to include, but I don't really need to spend time on the video necessarily writing it down. You can kind of take your time and write it down, pause the video, and write it down at your own pace. But there were a few things that I wanted to write down during the video just so I can explain it as I write down. Okay, so I'll talk about each box, but I may not write something for each box because I may have already written something in the box. Okay, so Unit 1 is all about limits and continuity. It was the first thing we learned at the beginning of the year. Just starting off in this first box, this is about determining a limit, very basic, very introductory, just reminding you of the limit notation. This is read limit of f of x as x approaches a. So the way you first start off to determine what the limit is you just try to simply plug in into where x is and figure out if you can get a value out of that. If you get a value out of that, meaning if you get some number when you plug in a, then you're done. That's the limit. But if you don't get an exact value, like a finite number, you get like a fraction 0 over 0 or infinity over infinity, that leads us to the L'Hopital's rule, which we can use. But it can only be used in these two cases. If you had a fraction as your function, and you got 0 over 0 or infinity over infinity. So I'll talk about the L'Hopital's rule in just a couple of minutes. The next box is definition of continuity. If any of the free response problems ask you, is a function continuous at some point, you need to show these three things right here. The first thing is the limit the limit of the function from the left and the right are equal to each other. And so what that means is that graphically, the function from either side of this point A is approaching the same value. Okay, we don't know necessarily that the coordinate exists though, so in order to see if it's continuous, we need to know if this line is connected at some point. The next thing is plugging in a into the function, so seeing if that point itself exists, the coordinate itself is defined. It's a shaded dot. And then the last thing is making sure that the limit and that shaded dot are the same thing, because there might be a problem where you have a hole right here and the shaded dot is defined somewhere else. That's not continuous, because in order for me to draw this, I have to lift up my pen, draw the dot, and then continue to draw it. That's not continuous because I have to lift up my pencil. The way that you have continuity is if the limit from either side approaches the same value, and that value is the point right there defined. That's the definition of continuity. Okay. The next one is if you get a limit as x approaches infinity. So that means that you have x is going towards infinity, and it's usually going to be in this fraction form. And so we use that acronym BOLOBOT DENITS DC, and you're just comparing the degree of the numerator to the denominator and seeing which one of these three does it fit into. Based on which one it fits into, you'll know what your limit approaches. L'Hopital's rule now is an important topic because it will most likely, or there's a high probability that it shows up on the test. Okay, so L'Hopital's rule is if I have some limit as x approaches a is some number, and I have this function f of x over g of x. At the top, I'll write if you get 0 over 0 or infinity over infinity, then you can use this. Okay, so that's a big key idea. You can't just use L'Hopital's rule for any limit. It has to be 0 over 0 or infinity when you first plug in a. So if I get these indeterminate forms, then this limit is equal to the limit of the derivatives of the numerator and the denominator. So I can reapply the limit again as x approaches a, but now I take the derivative of the numerator and the derivative of the denominator, and I plug in a again. Now let's say that you again get 0 over 0 or infinity over infinity, then you can continue to reapply L'Hopital's rule until you get a value for your answer. So I can continue this one more time, and I can say this is equal to the limit as x approaches a of f double prime of x over g double prime of x. You can keep going with the next derivatives. You can even go to the third derivative, fourth derivative if necessary. So just keep reapplying it until you get a finite value. That's the L'Hopital's rule. I'll put ... so you know you can continue L'Hopital's rule. Okay. All right, here's the next box at the very bottom. This is squeeze theorem. Squeeze theorem, you will easily identify when you need to use this. You will use squeeze theorem if you see three functions in a problem, or if the part in the problem introduces a third function, you might be using squeeze theorem, and if you see a limit or something like that there, it could be the squeeze theorem. So the squeeze theorem is saying if you have three functions such that I'll use f of x is less than g of x is less than h of x. So you have these three functions, f, g, and h. Now what squeeze theorem says is that, I'll say and, you know that the limit as x approaches some number for, I'm going to use f of x for this first one, is equal to, and I'll use h of x for the other one, because what squeeze theorem is saying is you have these three functions and they're kind of in a sequential order, meaning f of x is less than g of x is less than h of x. So one is on top of the other is on top of the other. What it's saying is that the top and the bottom one, if their limits are the same at a certain point, then the middle one has to also have that same limit. So here, the limit of f of x and the limit of h of x. So I chose, or I see this top one and this very bottom one, the greatest and the least function. If their limits, I need to erase this and use the right color here. Okay, limit as x approaches a. If those two limits are equal to the same value, so I'm going to put equals some number L. If those two limits are the same, then we can conclude that the middle function also has the same limit at this point A. So I'm going to put, then we know that the limit as x approaches the same number A as we used in the previous two limits of the middle function g of x is also equal to L. Okay, this is what it looks like visually. I'm going to draw a graph so you can kind of understand this a little bit more clearly. So if I had this graph down here, and I'll use, so f of x was the least function at the bottom. I'll use blue for g, and it's in between f and h. So I'll use red for h. Okay, so I intentionally drew it like this because I wanted to match the squeeze, what the squeeze theorem is saying. Okay, we already established that this if statement, these two limits have to equal each other, has to equal the same value. So what I did was I drew my picture such that the red graph, which is h, and the green graph, which is f, the greatest and the least one, had the same limit at some point A. So I'm going to put that point A down here, A. Okay, notice how they all kind of join and meet in here. Okay, now we already established also that this inequality should hold for these three functions. So g of x has to be in between f and h. So by the squeeze theorem, what it's saying is if this is true and these two have the same limit, then the third one that's in between has to be squeezed in between there, and it has to be the same limit as well. So that's where we get this. And so this y value here should be an L, where these three functions kind of come closer together, and that's called the squeeze theorem. All right. And the last one is the intermediate value theorem. Okay, the intermediate value theorem is also an if-then statement. Every theorem is an if something, then something else. So the intermediate value theorem, intermediate meaning in between, says that if f of x is continuous, so we have some function that's continuous on an interval a to b, and we have f of a is less than w, some new number, is less than f of b, then there exists at least one value c where f of c equals the w that was introduced in the if statement. So what this looks like is, I'm going to illustrate it down here using a picture. So we have this graph right here, and I'm going to draw the if statement. In the if statement, we have an interval a to b. So I'm going to draw a here and b here. F of x is continuous, so I have some function, and we also have that f of a is less than w is less than f of b. So if I already have a and b on the x-axis, then I need to have f of a and f of b on the y-axis. I drew them like this because it's telling me that f of a is less than f of b, and there's some w in between there. So I'm going to mark this w somewhere in here. Okay. Now I need to draw my function. So f of a and a should match up. F of b and b should match up on this coordinate plane. And we need to draw a function that's continuous in between a and b. So I have to keep my pencil on the paper when I draw it. It could be any function. I just have to keep my pen touching the screen when I draw it. I can't pick up my pen. So this is a continuous function in between a and b. And w is, it looks like it's somewhere right here. Okay. So what the intermediate value theorem is telling me now is that there has to be one value c such that f of c equals w. So f of c, so this x coordinate down here is c, and f of c is equal to w. And this is called the intermediate value theorem. In layman's terms, it's just saying that if this line is continuous in between here, then there has to be a point, an x value defined for every single y value defined in here. Okay, because the function is continuous. I have to be able to find some number in between a and b, because w is in between f of b and f of a. Okay, I'm going to attach some more videos as well from Khan Academy and some other resources on YouTube, just so you can kind of look through this limits unit. I'm also going to make free response question, not make free response question, make videos for free response questions that had these concepts in them, and I'm going to link them in the Unit 1 module on my website. But if you have questions about anything on this study guide so far, please let me know. I'm going to also be making videos for the rest of the unit study guides, so be on the lookout for those as well.